For regular videos on ancient cultures and forgotten civilizations, please subscribe.
Today we're going to look at evidence that thousands of years ago, ancient people knew how to measure the Earth. Yes, that's right, our planet, accurately. And that they encoded these measurements in the Great Pyramid of Giza in Egypt. You might think this sounds like a ludicrous proposition, and yet some people actually believe this. And I want to look at the arguments of one of the foremost proponents of this idea, Randall Carlson. Does Carlson make a good case? Let's look at his evidence together and see. Do you like do-it-yourself history? I do. And one form of history that is super fun to work with is your own family history. That's why I want to tell you about the sponsor of today's video, MyHeritage. What MyHeritage does is provide you with over 19 billion records, all at your fingertips, which you can then use to piece together your family's genealogy. They make it easy and fun to build your family tree and discover your origins. So, record matches. It will take you over here, and there's someone in there that matches, and we can review the match. And look, seems to be him. Look at all these new people, new information that I don't have in my tree. Now check these out, discoveries. Okay, these are people that MyHeritage discovered for me. This is instant discovery. Let's check out one. Susanna Pavlison. It looks like we have the same person. Look at the dates match. Same person. This is going to add 12 people to my tree. There also is an AI feature where you can take an old photo and enhance it and colorize it. Check out this photo of my mother's mother from 1922. It looks so much clearer and more real. You can even animate it. Then you can take these photos and put them right into your ancestor's profile. So if you're interested in your genealogy and family history, I can think of no better service. Below the video, I will leave a special link which MyHeritage has given me to offer to my viewers, and with it, you can sign up for a 14-day free trial and enjoy all of MyHeritage's amazing features. Welcome to the Myths of Ancient History series, in which I consider popular misrepresentations of the ancient past and show you exactly where they go wrong. You might know that the experts in academia don't accept these ideas, but maybe you think they don't have a good reason. Well, I'm going to show you the reasons. I hope this information proves helpful to you in the future. You may be familiar with Randall Carlson. He has appeared on the Joe Rogan Experience many times, and there are videos galore by him or about him on YouTube. Even I have done a video about him before, an examination of his claim that it is nigh near impossible for artifacts, other than stone ones, to last 10,000 years. If you haven't seen it, maybe you'd like to watch it after this one. Carlson, who refers to himself as a renegade scholar, has a podcast too, and one of his favorite topics is sacred geometry. He even sells courses on the subject through the website Sacred Geometry International. The YouTube channel After School has some videos featuring Carlson, and one of them, titled Hidden Mathematics, has over 4 million views. This video is basically a talk given by Randall a number of years ago, with some fancy new animations added. Although the video is 3 years old, it was the fullest presentation of Carlson's views about the geometry of the Great Pyramid I could find, and as far as I know, he still holds to these views. When the video came out, Carlson made a brand new intro for it, so at least at that time, he was standing by it. And the video has had considerable influence, so it needs a response.
Hello, I'm Randall Carlson, and I would like to welcome you to a very special episode of After School. I'm a designer and builder by profession, but have for many years been an avid investigator into the marvels and mysteries of this amazing world we inhabit. I would like to invite you to join us here on a journey into the realm of sacred number and symbol, and the forms, patterns, and cycles of both space and time in which these numbers are embedded. Today, thanks to the talented team at After School, we'll take a peek behind the veil into the ancient symbolism of sacred number that still exists as part of our everyday lives.
The Carlson After School video is 2 hours long, and there's no way I can respond to every detail without boring you to death. So we're going to focus on his arguments regarding the Great Pyramid, and anything related to that. This still will get long, so feel free to watch my video in chunks if need be. I will have a table of contents below.
The history of man may be far longer and stranger than we think. The Great Pyramid may indeed not fit in with what we believe about the past and the nature of the world. Thousands of years ago, someone measured the Earth with remarkable accuracy and recorded this information in the dimensions of the largest and possibly the oldest stone building on the planet. William R. Fix.
William R. Fix, in case you didn't know, is a disciple of the clairvoyant Edgar Cayce and an author of books about the paranormal. This quotation, which Carlson leads with, is the thesis that he's attempting to substantiate. He believes that the Earth's measurements are recorded in the dimensions of the Great Pyramid. Let's be clear here. He's not saying that there is an inscription in or on the pyramid that explicitly tells its readers, "Here are the measurements of the Earth." He's saying only that some of the measurements taken of the pyramid match also the measurements of the Earth. Well, obviously not exactly, that would be impossible. The pyramid is much smaller than the Earth. It requires an adjustment of the units of measurement being used or some further math to increase the size of the pyramid and obtain a match. So let's see what correspondences he comes up with and how amazing they actually are. First, some introductory remarks about the Great Pyramid itself.
Generally, the age of the pyramid is given around 4,200 years. It's roughly about the same age as the Sphinx.
Yes, that is approximately correct. Carbon dating of the pyramid's original mortar places the Great Pyramid in the 3rd millennium BCE, and original workers' marks made on stones inside, and documents found written by some others of the workers, place the construction of the pyramid in the reign of King Khufu, whose reign can be determined from Egyptian records as being in the 3rd millennium. Luminescence dating of the temples made here, including the Sphinx Temple, also indicates the same time period. You can get more details in my video on the dating of the Great Pyramid.
Some of you are probably familiar with the redating of the Sphinx by several geologists, primarily Robert Schoch from Boston University, who has studied the weathering of the limestone composing the Sphinx and the surrounding quarry that the Sphinx is situated in, and has determined that the rock has been severely weathered by water erosion. And of course, this Giza Plateau has been desert for the last 4,000 years, so it's not likely you're going to find severe water erosion on the Sphinx if it's only 4,000 years old. In fact, so severe is the water erosion that it's likely that the Sphinx is probably tens of thousands of years old. However, Robert Schoch, in most of his public presentations, usually places it at 7,000 to 9,000 years, but he's told he personally he just uses that because he's deliberately being very conservative because he's in the academic community, but he's perfectly willing to believe that could be much older than that.
I've gone and looked at all the geological papers written about the Sphinx, and Robert Schoch wrote the only ones I could find that claim the Sphinx is thousands of years older. So I don't know who Carlson is talking about when he speaks of several geologists, unless he means the ones that travel with the alt history folks on their tours, but who never published on it. I did a whole video on this subject in which you can get all the details, but what Carlson isn't telling you is that the vast majority of geologists who have studied the Sphinx disagree with Schoch. The fact is, between 12,000 and 5,500 years ago, the area around the Sphinx was completely flooded. And because the Sphinx body is made of such weak limestone, there is no way the Sphinx could have survived this flooding over thousands of years. That means the Sphinx has to be fewer than 5,500 years old. This is inconvenient geological evidence that Carlson ignores, and Robert Schoch too, for that matter.
And I've discussed the extent of the water erosion with him and discovered that he actually hasn't looked in depth at the comparable studies of rates of limestone weathering, which I spent a couple of months about 10 years ago studying, going around to various places where there were limestones and where you could see examples of limestone that had been weathered, and had looked at, read the literature that had been done on limestone weathering, and had concluded that, it would be a minimum of 20,000 years worth of weathering. And that's a minimum if you took the Sphinx and set it in a climate with rainfall, like say we've been having for the last 3 months, which would average out to about 45 inches a year. Even with rainfall like we've been seeing here in Atlanta in the last 3 months, it would take the Sphinx a minimum of 20 to 30,000 years to get the level of erosion.
So here Carlson tells his audience that he, the amateur geologist, did research for a couple of months, he says a couple of months, and found some important geological studies that Robert Schoch, the professional geologist who has been researching this specific subject for a lot longer, missed. And Carlson argues that you can actually date an artifact more precisely by the rate of weathering, despite the fact that all the world's geologists know that there are so many variables that come into play when it comes to weathering and erosion, that precise dating of an object is impossible when we can't quantify all the variables. In other words, Carlson wants not only to reject the geological scientific consensus about the Sphinx and choose to believe a geologist maverick on the subject, but also to correct this maverick. And why? Because Carlson wants to believe something, and in order to make it true, rejection of the views of the experts on the subject is necessary. But maybe Carlson can explain how rain could erode the Sphinx body if most of the body was underwater during all those thousands of years.
That raises the question regarding the Great Pyramid. Could it be as old? And I see no reason why not.
Except all the scientific dating methods that indicate otherwise. The reason for his tangent into the dating of the pyramid is because he is prepping his audience to be more receptive of his ultimate conclusion that the pyramid contains important information from times long before the days of ancient Egypt.
Problem here, though, is you know that the Great Pyramid was once covered in white limestone casing stones, highly polished, and according to Arabic traditions, pretty much all the Arabic traditions and legends about the Great Pyramid concur that the outside of the pyramid prior to the stripping of the casing stones was covered, completely covered in hieroglyphs.
I hadn't heard this one before, so I had to go check it. Is it true that pretty much all the Arabic traditions and legends concur that the outside of the pyramid was completely covered in hieroglyphs? There are Arabic stories about the expedition of the Abbasid Caliph al-Ma'mun in the 800s to search for ancient writings in Egypt. One source, Muhammad al-Idrisi, writing 300 years later, says that there was writing on the pyramids, which consisted of an identification of the builder of each pyramid, presumably in hieroglyphs, and then some wise sayings and other things, which were written in many different scripts, which were translatable. But nowhere does he say hieroglyphs covered the entire Great Pyramid, nor any other pyramid. The fact that the writings were in many different readable scripts suggests that a lot of it was graffiti put there by travelers over the centuries. Surviving limestone casing blocks from the Great Pyramid have no hieroglyphs on them. There are a few on the granite casing stones of the Menkaure Pyramid. I think Carlson is grossly exaggerating, don't you?
And one, it just boggles one's mind to contemplate what might have been written there. But clearly, I have a hard time imagining a greater act of vandalism in all of history than the stripping of those stones.
It sounds like Carlson is trying to create a new lost library narrative in the same vein as the Great Library of Alexandria or something. Indeed, the stripping of the casing stones is a real shame, and it may be that the name of the owner of the pyramid was on it. But a mind-boggling revelation covering the whole pyramid? This is just speculative fantasy. Keep in mind that we have material evidence for the growth and development of the Egyptian hieroglyphic script, from the most basic representations of names to full sentences over the course of time. And full writing did not appear until the early dynastic period about 5,000 years ago. So, if Carlson believes the Great Pyramid is thousands of years older than that, it would not have had hieroglyphs on it. It couldn't.
In fact, there had been efforts to get into the pyramid up until the time of Al-Mamun, which was, I think, around 1200 AD, but they were completely ineffectual.
Small point, but the expedition of Al-Mamun was in 832.
Anyways, they stripped off the stones, and as they stripped them off, there was a lot of rubble that fell down and buried the bottom of the pyramid, which turned out to be a good thing because it buried the bottom casing stones from those bottom and preserved them. And so from those, the various researchers could determine what the original exact angle of the pyramid was. And according to most calculations, it was around 51 degrees, 51 minutes, 14 seconds. I don't know if that level of accuracy is credible or not, but 51 degrees, 51 minutes would be. And from there, we can then determine what the geometry of the pyramid would have been and what its original height would have been simply by taking the tangent of that angle, 51 degrees, 51 minutes, and knowing the base length, one could calculate what the original height would have been to a high degree of accuracy.
I was interested in getting a little more information about the math here, and I'm not a math major. So I reached out to an acquaintance of mine, Caitlin Burnell, to get a mathematician's perspective on this. I wanted to be sure that I know what I'm talking about before I tell you. So I sent her the latest and most accurate measurements of the pyramid and a link to Carlson's video. I have with me here Caitlin Burnell, who is much better at math than me. She has been doing mathematics for a very long time, and I thought I'd ask her to come here and help us out a little bit when we're talking about these matters. So thank you for joining me today, Caitlin.
Pleasure to be here. So basically what we have to do, instead of taking a ruler and measuring the height of the current pyramid, is we have to use the slope of the stones that are left over that show us what slope they were using. And
that means there's some uncertainty.
Well, so the problem is we can measure these stones, but there is a bit of an error value. So this was measured by Petrie, I guess. I'm probably mispronouncing that name.
Petrie. I think it's Petrie.
Petrie? Okay. And it was measured with an error value 51 degrees and 52 minutes plus or minus 2 minutes. And so okay, let's use those angles. Let's see how that goes. So 51 degrees, 52 minutes plus or minus 2 minutes. And this leads to a height between 46.5 meters to 46.9 meters, wow. 40 centimeters of error or 16 inches of error. So what's the secret? What do people usually do? Usually people lean on the Egyptian angle measurement of the Sikhed. And most pyramids, knowing that the Egyptians use this angle measurement, most pyramids seem to be pretty close to a Sikhed of either 5 palms 1 finger or 5 palms 2 finger. I think the technical name for the fingers is actually digits, but I might be talking about digits of accuracy, so I'm just going to call them fingers to avoid any risk of confusion there.
Yes, okay.
So, here's a pyramid theorized to have a Sikhed of 5 palms 2 fingers. Here's a pyramid theorized to have a Sikhed of 5 palms 1 finger. This is the bent pyramid. This one is theorized in the bottom part to have been built with a Sikhed of 5 palms 0 fingers, but then they maybe realized it was going to be structurally unstable.
Could you explain what this measurement is? How do you get a slope out of this?
Yeah, and sorry, I should explain. In 1 cubit, there are 7 palms, and Sikheds are always expressed in terms of palms and fingers. Here I have a diagram of a Sikhed 5 palms. So that means if you have a 1 cubit long tall triangle, it'll be 5 palms, or 5/7 will be the height of the bottom part of the triangle. But what makes it, the reasons why you might want to have a height divisible by 7 is that if you scale this up, let's say you want to have a monumental building that's 70 cubits tall, right? That's a pretty tall building. Then you can have a base of 50 cubits. But if you try and do this with other numbers, if you try to do 60 cubits tall, it's okay, now you have to divide 60 by 7 and multiply by 5. That gets a little bit messy. So that's why a lot of the Egyptian buildings, a lot of the Egyptian pyramids were...
Oh, they want to keep it nice and simple, right? They want to keep it simple.
Yeah. It makes it really simple math to have a height divisible by 7.
So what you're saying is when they give, when they are calculating a slope, they figure, okay, how many cubits high and how many palms?
Yeah. Well, so for the Sikhed measurement, the height of the triangle is always assumed to be 1 cubit, but then they scale that up, right? So
I see. So always when they give an angle, they'll say 1 cubit by X.
Yeah. So they only give the bottom side of the triangle. So it'll be 5 palms or 5 palms 1 finger, 5 palms 2 fingers.
Got it. And so the two most common slopes are 5-1 and 5-2.
5-1 and 5-2, yeah. So I mean, I have another diagram here of with the 5 palms, 2 fingers of the sequence that. So if you built that, if the triangle had a height of 70 cubits, it would have a base of 55 cubits, for example.
So the
Yep.
Great Pyramid, is it just assumed it is 5'2", or do
It's
you
just
think it's
assumed it's
definitely
5-2, yeah. And it's
okay?
actually like if you go back to the original angle measurements, it's only barely within the error value of Petrie's angle measurements, but it is just barely within that error value. So it's just assumed that's the actual slope, near as I can tell.
Okay. And Khafre's pyramid is assumed to be 5'1".
Correct, yeah.
Okay. Um, and would you agree with those assessments? They seem to be the closest to being correct.
I actually haven't seen angle measurements with error values for Khafre's pyramid, but um based on like the current height, I think it couldn't work with 5-2, so 5-1 is certainly more reasonable. And like you can look online and find like Wikipedia will list like it'll seem to have this angle, but that angle, near as I can tell, is coming from the assumption that it's 5 palms, 1 finger.
All right. Now, how does this assumption of the Great Pyramid being 5 palms, 2 digits, and a slope compare to what Randall Carlson is saying?
So
Is he
this is
agreeing with
usually
it?
how we this is usually how we estimate the height. It's like you'll go
Uh,
you need an angle to estimate the height. So if you assume that the secant is exactly like perfectly 5 palms, 2 fingers, um, this is you will get a height measurement with a little bit less error. There's still some error on our measurements of the sides, but less error, right? So and that is he does use this. He um he uses these assumes the 7/11 ratio. Um, but I mean, there's still a problem here, which is like even if like 5 palms, 2 fingers was the second of intent for the Egyptians, they could have still gotten the angle wrong. Like we know they got the angle slightly wrong on all of the corners, right? The corners are not
yeah.
perfectly 90 degrees,
Hmm.
and like a small error by them in the angle, similar to the error in the corners, would lead to a substantially different height. So
So the Egyptians expressed an angle in the form of a second, and they measured in cubits, palms, and fingers, which were somewhat standardized, at least for each project. It makes sense to use their measurements before converting into our own. Carlson doesn't bother with all that, but it is correct to say that the height of the pyramid can be determined mathematically with the angle and the base length, assuming absolute accuracy in construction. But we have no reason to assume this.
J.H. Cole in 1925 did what's considered to be the definitive survey of the Great Pyramid. He was a professional surveyor who did a very meticulous survey after they had just cleared away all of the rubble, and he had access to it. He did it under contract to the government of Egypt. The numbers that I'm about to show you here are mostly derived from his survey.
More precise measuring has been done since 1925, so I'm not sure why Carlson has chosen to go with an older set of measurements, though I would presume that it's because he likes these measurements better than the more accurate recent ones. The best scientific measuring of the sides of the Great Pyramid was done by Mark Lehner and David Goodman in 1984, and the data has been published and analyzed by Glenn Dash in the article New Angles on the Great Pyramid. I'll leave a link to it below the video.
So what we have here is here's some of the original casing stones, and they sit on what's called a socle, which is this base, which was measured to be 55 centimeters in thickness. And of course, you got to bear in mind that this original slope casing stone, it wasn't stepped like that originally. It was a smooth profile. And okay. So here you have, of course, here you see that the casing stones were damaged by the rubble falling down, but enough of them were still intact that one could make this accurate determination of the original angle. Here's the socle, which is 55 centimeters thick, and it sits directly on bedrock. So what it does is it creates two ways that one could measure the height of the pyramid, either with or without the socle.
Since the platform on which the pyramid rests, what Carlson calls the socle, is not part of the pyramid itself, it's independent of the pyramid shape. It might seem inappropriate to use it when comparing to the dimensions of the Earth, but Carlson wants to use it because, as we will see, he found a correlation.
This is showing one of the sockets that's still there, that sits outside the core masonry. But based on those sockets, they were able to reconstruct what the original base of the pyramid would have looked like. So here would have been the 51 degrees, 51 minutes, coming down, sitting on the 55 centimeter thick socle here, like this. Well, what this did was it gave two ways of measuring the perimeter of the pyramid's base. One could be measured from this point up on top of the socle. The other could be measured from down here that included the socle. So what you ended up with was two ways of measuring the pyramid's base. Well, which one was the correct one? Well, they were both correct. I think that they were actually intending to embody in there that there were two ways of measuring the pyramid's base.
This is not really two ways of measuring the base. It's just two different bases that can be measured. Either the perimeter of the pyramid itself can be measured, or the perimeter of the pyramid platform can be measured. But Carlson wants to use both perimeter measurements. We'll find out why shortly. But in sacred geometry numerical exercises, the more measurements you can fill your quiver with, the greater the chance you can hit the target. By the way, Randall, this is a minor point, but you should spell check the word perimeter.
So what we have is the length of the base on the socle, which is the shorter of the two up there. It was varied from side to side. You'll notice 755 at the smallest to 756 just over at the largest. So there was some variation. There was probably a reason for that variation, actually, but we won't get into that because it just gets too technical for what we're talking about today.
This comment is very telling. Carlson is forced to acknowledge that the sides of the pyramids are not exactly equal. But as this would suggest that the builders were imprecise, and that would ruin his thesis, he says, there was probably a reason for the variation. I don't have time to get into it right now, though, but trust me, bro.
But the total of those measured around the four sides would be 3,023.139 feet. If you're taking notes, that'd be a good number to write down. Okay, so now let's see what the measure is around that includes the socle, or the base. And we see that each side is roughly 5 feet longer, 760 to 761. Each side, again, is a little different, but we get a total of 3,043.433 feet.
Yeah, the platform is not measured in a lot of surveys that have done the Great Pyramid. Carlson calls it a socle, but based on what he's highlighting here, most papers call it the platform. Using the Lerner Goodwin numbers, which were recommended to me by Dr. Miano, we come up with the perimeter for the platform being around 3,034 feet, plus or minus 0.3 feet. And this is a bit of a problem because his numbers here are actually off by about 10 feet. Yeah, the error value on the Lerner Goodwin numbers are plus or minus 0.3 feet. So my best guess is that he read a paper that said something like the platform is an extra 2.5 feet, but he assumed that was 2.5 feet in both directions, so he added 10 to each side, or 5 to each side, and then it was plus 20 over the base of the pyramid. But I don't really know how he came up with this number, but yeah, it's definitely not accurate, and this is unfortunately the number he uses the most going forward. So yeah, it's pretty far off.
So he's 10 feet too short or too long?
Too long.
Okay.
Yeah, the pyramid is sitting on a platform that's flat for a little bit and then starts sloping up at the slope of the pyramid, and so that one. He doubled the distance, the difference that was from it's about 10 feet longer all the way around than the base of the actual pyramid, but he has it being 20 feet longer for some reason.
I see. But then the casing perimeter would be the perimeter not including the base. So above the base?
Yeah, the casing perimeter is the actual pyramid. Those are the casing stones are the actual sloped stones, when back when the pyramid was a perfectly smooth all the way up. Those are the stones that those are the casing stones that are like look nice and are flat and actually have an angle, as opposed to the stones underneath that are like squares.
I see.
Moving on to the casing numbers he uses. Here's the casing numbers I get from the data Dr. Miano gave me in the Lerner Goodman numbers. And the casing numbers Randall Carlson gives is actually completely within the error value and is a pretty good match for Cole's 1925 survey, which is the one that he cites. So these ones are fine.
All right. So the one correlation that fits is this casing number?
So yeah, the one measurement he has is good as this casing number, and he does.
And which number is that? 3,023 feet?
Yeah, 3,023 is the one that's that's a pretty good measurement.
So now we're going to go back to the Earth so we can see how these numbers link the two. We take 1 square degree of latitude and longitude at the equator. Pretend we're standing at the equator. Okay, we know that the polar radius now is 13 miles less than the equatorial radius. So what that means is that the circle this way is shorter than the circle. The biggest circle that defines the Earth is the equatorial circle. So a degree of measure on the equator is going to be the biggest, the longest of any degree we measure anywhere on the Earth, the equator. Okay, the north-south is going to be a little bit shorter. And you'll notice right there, we've got 68.7 miles north to south and 69.17 east to west. So it's not a perfectly square unit, is it? It's a little bit distorted.
On this point about latitude and longitude, he is correct. If you're wondering why he is telling everyone this, it's because, as we shall see, he's going to argue that the latitude is encoded in the measurement of the perimeter of the pyramid, and the longitude is encoded in the measurement of the perimeter of the pyramid's platform. This, despite the fact that there is no clear reason to connect these measurements to latitude and longitude, and that the pyramid is nowhere near the equator.
Well, that distortion is totally significant because it's that distortion that is a measure of the Earth's departure from being a perfect sphere. And it's that departure of a perfect sphere that is very significant to us, because without that, again, Earth's orbital stability would be non-existent.
So here he seems to be giving a reason for why these numbers would be encoded in the pyramid. Something about how, without the equatorial bulge, the Earth's axis of rotation would wobble all over the place unstably, and this would be very bad for life on Earth. Did the pyramid builders not know about the conservation of angular momentum? It would be very difficult to get an already spinning Earth to wobble. Anyway, the equatorial bulge is created by the spinning, so speculating what its spinning would be like without the bulge is a bit pointless, isn't it?
Okay, so we're going to divide this up a little bit. If we take this square degree of latitude north to south, longitude east to west, and we look very carefully down in the lower right-hand corner, you're going to see something, a little square. You see that little square? That represents 1 minute, 1/60th of the degree this way, 1/60th of the degree this way. So that's 1 minute of latitude and longitude, all right? We're going to take a closer look at that, and we will see that 1 minute then is 6,045.881 north to south, 6,087 east to west, which is what we expect. The east-west should be a little bit longer. And that's 1 square minute of latitude and longitude.
Now, I would suppose that if Carlson could find 1 exact minute of latitude and longitude mysteriously encoded in the Great Pyramid, he could convince people that this was more than a coincidence. But he can't find 1 exact minute encoded in the Great Pyramid, so what does he do? Well, he needs to do a little finessing. Let's see.
Okay, now we're going to divide each of those lengths into 2. We're going to divide our square minute into 1/4 sections.
So why is he dividing the minute up and using 1/4 of it? He doesn't give a reason. And that is because there is no reason, except for one reason. And that reason is because he's trying to make it match the Great Pyramid, and the only way to do that is to divide the minute up into 4 parts. If that didn't work, he would have divided the minute up in a different way. Maybe 1/8 of a minute would work. Whatever he has to do. It's all part of his method. Pick the numbers that work.
And here's what I want you to notice. When we do that, we take 1/4 of a square minute of latitude and longitude. Look at our dimension east to west, and look at our dimension north to south. And look at these two numbers.
I'm trying to figure out why Carlson believes that the makers of the Great Pyramid would think to connect the measurement of the 4 sides of a quadrangle with the measurement of one side of a quadrangle. It doesn't seem intuitive to me. And notice that the numbers are still not exact, but they are within a foot, so maybe this is good enough to make people think there is something to this? I asked Caitlin what she thought about this.
So the Great Pyramid is really not near the equator at all. The Great Pyramid is so far north that 14% of the U.S. population lives to the south of the Great Pyramid. It's so far north that the north-south distance between the Great Pyramid and the equator is double the north-south distance between Orlando, Florida, and Burlington, Vermont. It's so far north that at some point I was trying to figure out like, hey, how did they get it? It's very north-south aligned, right? Like, how did they get it so north-south aligned? Did they use a zero shadow day? And I was like, no, they couldn't. They are way too far north to have a zero shadow day. So, I get why the Egyptians might care about longitude distance at the equator. These are going to be related to the circumference at the equator. But
So basically, by talking about what's going on at the equator, there really isn't a link with the pyramid.
Yeah, I mean, so like the longitudes measurements of the equator could still be somewhat relevant because those are gonna like if you add enough of those together, you get the circumference at the equator, and like no matter where you are, you could maybe care about the circumference at the equator. But like this other number, like yeah, latitude is not this like the distance of latitude is not the same everywhere on the Earth, but like that's only really relevant if you happen to be like making maps about the equator. Like if you are nowhere near the equator, which the pyramids aren't, you're really not going to care about very much about that number.
I assume his opinion is that, well, the Great Pyramid is just one of many great monuments that this wonderful civilization built, and they were concerned about the whole Earth, So yeah, even though the Great Pyramid is not near the equator, they knew about the equator, and it was.
Yeah, I mean, but the thing is, like, there's way better ways to show that you know about the bulge of the Earth. Like, you could do the polar circumference and the circumference of the equator. You could do like the polar radius and the radius at the equator. And he actually does relate the Great Pyramid to the polar radius, right? Like he's trying to make that argument, but this specific number, the gap between latitude lines at the equator, like that's people like unless you are actually making maps about that specific region, you're not going to care that much. And like he actually does a whole lot more with the longitude number later on. He's going to do a whole lot of tricks with that number, but he doesn't really have very much to say about. Even though he makes a big deal about lining up the latitude number as well, he doesn't really do anything with it because there's not that much you can do with it unless you're specifically making maps at the equator.
With this correlation alone, Carlson hasn't made the best case that the makers of the Great Pyramid encoded the measurements of the Earth into the pyramid. Not only because his measurement for the perimeter of the pyramid platform is wrong, but also because it assumes that the geographic coordinate system that we use today is the same one that the makers of the pyramid used, and he knows he needs something better than this. So, he presents what appears to be an even more impressive correlation. But in order for Carlson to reveal this correlation, he is unable simply to take the measurements of the pyramid and compare them to the measurements of the Earth, as he did here. This time, that won't be enough. He must also bring into the mix a set of other numbers, which he calls sacred numbers. This is how he describes them.
So if you just listen to these numbers, look at them, and let them kind of soak into your brain, Once you've gotten into this as actually a system, a methodology of transmitting information, these numbers are actually carriers of information because each number stands for meanings beyond just the apparent ones.
So these special numbers, which are based on our units of time, he thinks contain meaning beyond just the apparent ones. He argues for the existence of many sacred numbers, but the important one for the Great Pyramid, he will point out, is 43,200. He needs this number in order to make it all work. But how does he determine that 43,200 specifically is a sacred number known by the builders of the pyramid? Well, to do that, he has to go outside of Egypt. This is from earlier in the talk.
Okay, we've seen this. So this is just a recap of those same numbers. And you will notice 8640, the number of seconds in one day. You'll notice that in a half a day, 43,200. Well, if you go back to the dawning of the age of Aries, 4,320 years ago.
Okay, so 43,200 is the number of seconds in half a day. Why half a day? Well, because that is the number he needs. And he shows how, look, if you divide that by 10, you get 4,320, which is exactly the number of years before present that the age of Aries began. And no, I don't know why he's counting back from the present and acting like the ancients also did. But he's trying to link the two, the age of Aries and the number of seconds in half a day. They are the same, except for the extra zero, right? But you see, what Carlson doesn't tell his audience here is that his number for the full cycle of the ages, 25,920 years, is an invention. An age of this length was never mentioned by the ancients. The period of the Earth's axial precession is approximately 26,000 years. You can't give it an exact number because the period is not exactly constant. And yet he fixes the cycle at 25,920 years. This is so he can divide it up into 12 equal parts and get 2,160 years for each age. And then you can add two ages together and get 4,320. Then you can multiply that by 10, just because, and voila! A sacred number important for the Great Pyramid.
The book of Revelations has 404 verses. Add the number of people at the Last Supper, minus the number of Filipinos in the Bible, and you get
3,100,000.
3:15 p.m., May 18th.
But two questions arise. Maybe you have thought of them too. What was the purpose the ancients had for adding up the length of two ages to get 4,320? And why would they then, having so far used multiples of the number 12 or 60, then decide to multiply it by 10? I couldn't find an answer to these in Carlson's talk. Let's see what else he's got to get his special number.
In ancient Sumeria, from the various writings of historians like Berossus and others, and from the Sumerian clay tablets, we're able to find that there were references to 10 pre- or antediluvian kings. What does pre-diluvian mean? Before the flood, right. So they had this belief that there were 10 kings reigning before the flood. And you'll notice the numbers that they ascribed to each of the kings, the reign. Those numbers now should all be becoming familiar to you. You've seen a bunch of them already. There's 43,200, 64,800, 36. You'll notice 64,800 is presented twice, actually three times. The total, though, 432,000 years.
To be clear, this information was not found on any Sumerian clay tablets. It actually comes from a Christian writer named George Synkellis, who lived in the 800s CE and wrote a work in Greek called Extract of Chronography. He says he got it from an earlier Greek writer named Abydos, who lived sometime between 100 and 300 CE, and wrote a book on the history of Assyria and Babylon. Abydos' work has not survived, but Abydos says, regarding this chronology, that he was quoting from a work by Berossus, a Babylonian priest, He lived in the 3rd century BCE, and his book was a history of Babylonia, which he also wrote in Greek. Berosus' work no longer exists either. Now that we have found a copy of the actual Sumerian king list in Sumerian, which is much older than Berosus, and there is some similarity, we know that Berosus probably had some copies in his time and made a translation. But if Carlson can use a translation of the actual Sumerian king list, why does he not use it? Well, let's take a look at the actual Sumerian king list. And what do we see? It's a bit different from Berosus, isn't it? This is because over the centuries, the list was copied many times and errors crept into it. Somewhere along the way it got garbled. But you see, only the later version works for Carlson, so that's what he's going with. As is his custom, he selects whatever works. Oh, and just so you know, the oldest version of the Sumerian king list ever found, which is nearly 2,000 years older than Berosus, has no pre-Diluvian kings at all. That's because the list of pre-Diluvian kings was invented later. And yes, After School made some nice graphics here, but he spelled pre-Diluvian wrong. And if you're impressed that a lot of the same numbers keep coming up, don't be too surprised. They are all just multiples of the number 360. Remember, the Sumerians used a sexagesimal system, and in fact, Berosus records the lengths of the reigns of these kings not in years, but in sars, and one sar, as Berosus himself says, is 3,600 years long. Therefore, every reign here will be divisible by 3,600.
In the Vayu Purana, which is again one of the Vedas.
The Vayu Purana is not one of the Vedas. Scholars date it to between 350 BCE and 500 CE. So it's ancient, but not as ancient as Carlson would have you believe.
We find verses like this: 360 years, according to the human calculation, constitute one divine year. Wise people know that there are 4 yugas in Bharatavarsa. The first one is Kreta, then follow Treta, Dvapara, and Kali. Probably some of you have heard of the Kali Yuga that we're supposedly in right now, and supposed the age of darkness and the age of ignorance. But you'll notice that they reckon time. They have another. The Vedas recognize as a sacred year that they call, or a divine year, which is 360 of our years.
If you're wondering why the number 360 keeps popping up, this is because it is the approximate length of a lunar year. Lunar years vary in length, but ancient priests thought it was convenient to make a perfect lunar year of 12 months of 30 days each. 360. There's nothing about it that suggests an advanced early civilization had to have come up with it. So if 360 months equals 1 year, it's not a stretch to think some people believed 360 years adds up to a special divine year. To get Carlson's magic number of 43,200, all you have to do is multiply 360 by 120. Let's see how he does it.
Okay, now here's a tabulation of the Vedic ages. And you'll notice, we'll look first at the total in human years, and we see that the Kali Yuga, the shortest, is 432,000. And then we go to 864,000, 1,296,000, 1,728,000, and 4,320,000. You'll notice that the total, or the Mahayuga, the Great Yuga, is 10 times the length of the Kali Yuga. And that's because you'll notice that the Dwapara is twice, the Treta is 3 times, and the Satya is 4 times. So taking the original term, doubling it, then tripling it, then quadrupling it, adding those together will give us 10 times the number we started with. But again, notice the number that the Vedic ages begins with. 432,000 is the same number that the Sumerian king list ends with.
Yes, that is because everyone is using multiples of 360. It is therefore not surprising.
So it's almost as if we have 2 different traditions, but one system. And we see that the Sumerians preserved knowledge about the subdivisions of this Yuga time of 432,000 years, and symbolize these subdivisions by the reigns of these 10 pre-Diluvian kings. And then we can see that once we get to 432,000 years, at that point the Vedic cycles kick in, and then we have these that follow.
Someone needs to ask Randall this very important question. What actual knowledge does he think is being preserved? What we have here are people inventing a system of ages based on the number 360. And I say inventing because no real history is going to play out so schematically. So that in itself isn't knowledge. So what makes it knowledge? If he finds similarities between Mesopotamian and Indian numbers or ages, okay, that's cool. But that could very well be because they had been in contact with each other. How does that lead him to the conclusion that they are preserving knowledge? He would have you believe that these systems go way back before these people. But they don't. We have already seen that the older Sumerian king list is different from Berosus, and the oldest Sumerian king list doesn't even have the pre-Diluvian kings at all. His two sources, the Vayu Purana and Berosus, are relatively late texts in comparison to what else we have, and neither of them are Egyptian. But he nevertheless wants to apply them to the Great Pyramid. We have mathematical texts from ancient Egypt. Why isn't he using any of those? Well, I expect he looked through them, but couldn't find his magic number of 43,200.
Okay, so I'm going to write down a few numbers that we saw through our radius of the moon, diameter of the moon, radius of the sun, diameter of the sun, number of seconds in a day would be 43,200. Number of seconds in a half a day, number of seconds in a full day, 86,400. What were some of our other numbers? Oh yeah, 1440 was one, 7920. Diameter of the earth, just so they're up there in front of you, we can refer to them.
Is it just me, or do you also feel like you're watching someone about to perform a magic trick? Note how the numbers are all rounded. For someone interested in precision, this is curious. The radius of the earth, by the way, is 432,690 miles, which is closer to 433,000.
So here is profile the Great Pyramid with a 51 degree, 51 minute angle. To make it easy, I've just rounded off the numbers, 481 feet in height. That would be not including the socle, the base. 755.85, I just picked one to use. And there's our 51 degree, 51 minute angle. And we find that when we measure it this way, it turns out to be almost exactly 11/7. There's some other interesting geometry going on related to the golden section, which I don't intend to get into today because it makes more sense if you're actually studying sacred geometry and you're familiar and you've made these drawings. Because in a sacred geometry class, just like in the old Pythagorean and Platonic lodges, we draw, and then we eventually build models. And that's the way to really get familiar with this and get these numbers as part of your consciousness.
In case you're wondering, golden section is another way of saying the golden ratio. But Carlson believes that you can't fully understand matters relating to the golden ratio unless you spend some time learning sacred geometry, as they did in the old Pythagorean Platonic lodges, and get it into your consciousness. Ooh-wee-oo. But the fact is, you can learn about the golden ratio when you study math. You don't need to become a disciple of any esoteric or spiritual movements to know everything you need to know. And let's be clear here. Sacred geometry is spirituality, not science. Pythagoreanism was a religion. Neoplatonism was a religion. They both were heavily philosophical, but they were religious, and they influenced medieval mysticism, which is what led to the lodges that Carlson is talking about.
When we measure including the socle, this becomes our height, 482.7575 feet, and the base, 760.9 feet. Okay, those are the numbers we're going to look at for a second here now. if we look at these are various estimates. We're looking at this one right here, the coal height estimate plus the sockle at 21.6 inches gives a total of the height above bedrock of 482.7575 feet.
So let's talk about the height of the Great Pyramid and how we
And we know
actually.
exactly how high it was, right?
Well, um, I mean, so here's a bunch of different published papers. And you can see there's a bit of a variation in published research papers of what the height is. People say to report heights between 46.5 meters and 46.8 meters. Um,
Is that close enough for Randall Carlson's calculations?
no, I mean, this leads like he claims it super accurately measures the polar radius, but not at all. Like it's being off by so it's off by about a foot, like up or down by about a foot, right? And being a foot taller or a foot shorter leads to your measurement being off by about 8 miles once you scale it up by 43,200.
Oh, If people assume it's 440 cubits on the side and 280 cubits tall, is that reasonable, or are they putting too much faith in those numbers?
I mean that's fairly reasonable, I think, but we still don't know exactly how long a cubit is, and we do have like a roughly a foot error measurement of the perimeter, so it's like roughly a fifth of a foot for like that still gives an aggregate like yeah, I mean it would still give like a even if you make that assumption, you still have like probably 2-3 inches of error. And
Mhm.
he like for the accuracy he's claiming, he needs it to be within 1/16 of an inch.
Oh, 1/16 of an inch.
Yeah.
And we're nowhere near that, right?
Yeah, like like even if you just assume their angles were perfect, they made no errors in their um their secant of 5 palms 2 fingers, like our error measurement on the sides, in fact their slight errors on the sides are still like like a couple
Mhm.
inches, right? Like
Yeah. But if someone says, and I often get objections like this, if someone
uh-huh,
says, well, you're just saying we don't know, but you didn't disprove it.
sure. Um
What would you say about
I,
that?
but
Like
I mean
it
like
could
there's a
be,
lot of like there's so much error value in there. Like I mean our error value of the slope is like people will claim they see these other numbers in the pyramid like pi and the golden ratio, and like the error between like 11/7 as a way to approximate those numbers, and
oh yeah,
uh,
could you
those
explain?
numbers.
Yeah, could you tell the audience why a 7-11 ratio is significant?
So okay, did the Egyptians know 3 + 1/7 as an approximation for pi? And I mean, like I can't say definitely not, like definitely absolutely not, but probably not based on we have like this rhymed mathematical papyrus, we have the Moscow mathematical papyrus, and so here's
You're by the way, you're debunking me because in a previous video I said, yeah, the Egyptians knew pi. It's in the Rhind papyrus. Are you telling me I'm wrong?
well they had a version of pi in the Rhine papyrus, but the thing is like before I tell you what that version is, I gotta say there's 5 reasonable constants you could use to describe a circle, right? You could use pi, which is what we use. There's a bunch of people on the internet trying to convince everyone to switch to tau, which is roughly 2 pi, or exactly 2 pi. Or you could use like pi/4 if you were just, you wanted to calculate um, the area of a circle just from the diameter. You didn't like using radiuses, you could use pi/4. Or if you were just interested in using um, getting the area, but you wanted to multiply your constant before you squared it, you could use the square root of pi or the square root of pi/4. Um, the Egyptians in the Rhine papyrus and in the Moscow papyrus used this one. They used the square root of pi over 4. And the approximation they knew for this one was 8 over 9. So I mean, like, and it's actually it's a really good approximation of the square root of pi over 4. Not as good as 3 plus 1/7, but like you can't get better without going into double digit numbers.
But since pi is in the equation, wouldn't that mean that they knew pi? They have to stick it into the equation.
Yeah, but I mean, like, can you tell me how many digits of the square root of pi over 4 can you tell me, right? Like,
Oh, I see. Yeah.
right? I until I look this up, like it's like 0.886 or something like that. But until I look this up, like I would have known like 0 or 1, right? Like, so I mean, they would have looked at this and thought, we look at like 22 over 7 or 11 over 7, we think, oh, that's a circle number, right? But for the ancient Egyptians, they would have looked at 8 over 9 in thought circle. They wouldn't have necessarily looked at like 11 over 7 or 11 over 14 in thought circle, right?
Uh-huh.
Um,
Is that a gimel? What is that? What do you call that symbol?
yeah, I use Hebrew letters for the remaining symbols. So there's a bet, there's an aleph, and there's a gimel.
Wait, but is that what mathematicians use?
I mean, no one has proposed symbols for these other
So these are your inventions.
these are my invention, yeah.
Okay. All right. So but you think that this is, so you basically came up with a symbol for this formula.
Yeah, I mean, so pi and tau are pretty well established. Like people have symbols for both of those.
But what about the
I don't
square
know
root
of
of pi over 4?
Yeah, no, like I haven't seen any proposed symbols for pi over 4 or the square root of pi or the square root of pi over 4.
But the square root of pi over 4, is it used to figure out the area of a circle?
Yeah, so what you could do, and interestingly, I think I actually might have like I have some relatives who live on a farm, and I think actually some of them might use this, but I can't. I was trying to like it's been like 20 years since they mentioned it, but they had some approximation of pi where they took the diameter of the grain silo and they multiplied it by something. Maybe it was 8 over 9. I'm not sure. And like all you do is you take your diameter. Let's say your diameter is 9 feet across or whatever. You multiply by 8 over 9. You square that, and that gives you a pretty good approximation of the area of that circle.
Mm-hmm. Okay, cool. Very cool.
Yeah.
And you think that that's most likely what they would have done?
Well, that is what they did every single time in both the Rhine mathematical papyrus and the Moscow mathematical
so
papyrus.
it's not, you don't think, that's exactly how they did it.
Yeah, well, I mean, it's possible. So I mean, the Moscow mathematical papyrus is dated to, I think, like 1800 BCE, and the Rhine mathematical papyrus is like 1600 BCE. So these are like 600 years after the event. So we don't like 100% know for sure, but like pi comes up several times in both of them, and they use 8 over 9 every single time.
Ah, I see. Okay.
Here's an accurate calculation. We take the 482.755 feet, which is the height, and what we discover is that if we multiply that by the number 43,200, which is one of our sacred numbers that we've seen right there, 43,200, it shows up in the Vedas, in the Sumerian king lists, etc., etc. If we multiply the height of the pyramid by that number, this is what we come out with, 3,949.83 miles. And notice the difference between the pyramid, which I call the standard polar radius, and World Grid System 72 is only 313 feet over the entire size of the Earth.
So here Carlson tries to wow his audience by showing that if you add the height of the pyramid to the height of the platform and multiply that number by 43,200, one of his personally chosen sacred numbers, you get the polar radius of the Earth. All of this was done backwards, of course. He needed the number 43,200, so he went and found it in some sacred texts. It didn't matter which sacred text, and he could choose whatever number in a sacred text that he wanted. And of course, using the system of measuring time, he found that 43,200 seconds were in half a day. So he used it. He needed to make it work, so he made it work.
So we have essentially the pyramid being a scale model of the Earth, the northern hemisphere, at a scale of 43,200 to 1.
If the pyramid were a scale model of the Earth, it would be in the same shape as the Earth, wouldn't it?
If we take the pyramid, enlarge it by 43,200, its height, including the socle, now becomes the polar radius of the Earth within 300 feet of our satellite surveys. Then the two measures of the base are exactly the difference between the east-west difference and the north-south difference at a square minute at the equator. You can take the surveys of Egypt by Cole. You can take the geodetic surveys. I didn't make those numbers up, or I didn't fudge them.
But we have already seen that you did fudge some of the numbers, and the sacred numbers are made up.
And what you discover is that when you expand it by 43,200, which, you know, if the number was just some arbitrary number, but it turns out that the factor of expansion turns out to be one of the critical sacred numbers within the ancient systems.
Out of all the numbers that are written in ancient documents, for a whole host of reasons, what is the method you used for selecting which ones are the critical ones? It seems completely arbitrary to me. Take a look at his numbers there on the left. Ask yourself, did the ancient people use the decimal system? The Sumerians, we know, used a sexagesimal system, but when Carlson adds zeros to the number 43,200, he is multiplying by a factor of 10. This is decimal, not sexagesimal. Certainly not the way the ancient Mesopotamians would have played with these numbers.
And so here we have the pyramid now, enlarged by 43,200 times. And another way to think of it is if we go back to this diagram right here, you'll see that as the Earth turns, every half second, it's going to turn this far. So it means that every 2 seconds, the Earth, if you're standing on the equator, in 2 seconds, the Earth has turned 143,200th part of its total orbit. So if you're standing on the equator, in 2 seconds precisely, the Earth has turned a distance exactly equal to the distance around the base of the Great Pyramid.
He's saying that, at the equator, you rotate 43,200ths of the Earth's rotation every 2 seconds, and this is true, right? Like this lines up with his definition of the second, and even at the very start of the talk, he mentions there's 43,200 seconds in 12 hours, right? So half of a day. So, when you go up to 2 seconds, now it's 24 hours, right? So this is not surprising at all. But he also claims that this lines up with the pyramid.
Okay.
So
Also, one of the kings in the Babylonian king list reigned 43,200 years.
Yeah, right. Except the number he gets out of the Babylonian kings list is off by a factor of 10, and the number he gets out of the betas, well, one of them is off by a factor of 10, and the other one is off by a factor of 100. So not really, but
okay. So and why does he make it 2 seconds instead of 1 second?
Well, because he doesn't really have a choice here.
Okay. So it's the only way it'll work.
Yeah, sure. It would probably be nicer for him if the scale was 1 to 864,000. I guess he should have used a different pyramid. Like Pyramid of Menkaure maybe was like about half the size of the Great Pyramid. Maybe that would work better for him. But
okay.
Pyramid of Khafre, Great Pyramid, sorry, is a little bit too big.
Okay. But as far as his measurement here, yes, it is every 2 seconds. It is 1 43,200th of
Yeah.
the orbit. Okay.
But it's just a strange, strange way with measuring speed, right? Like usually you do like speed per second or speed per kilometer. This is like speed per 2 seconds.
Hmm.
Um,
Okay. All right. So he says if you multiply his pyramid measurement. Now, what pyramid measurement is that? His
so this is he doesn't actually say this, and
okay.
I'm actually bringing this up because I think he's trying to like make it look a little bit more special than it is. But basically, all this like fancy like rotation of the Earth corresponds to every 2 seconds you go around the pyramid one time if you're at the equator. Like all this really means is that if you multiply his perimeter around the equator by 43,200,
You mean
you'll get the
his perimeter
circumference of the
around the
Earth.
pyramid?
Hmm?
You said his perimeter around the equator.
Yeah. So well, it's his perimeter around the socle or the
Okay.
platform.
Yeah.
So I mean, here's his number. And let's multiply this by 40,200, and hey, look at that! Like it really does line up almost perfectly with the
Circumference of
circumference
the
of the
Earth.
equator.
Whoa! So he has something here then, right?
But the measurement is just wrong, right? Like this is not the perimeter of the platform or what he calls the socle.
Yes. Okay. Okay. So in this particular situation, it's just that he gets the measurement of the socle wrong, so it doesn't work out.
Yeah.
But if his measurement of the socle was correct, then it would work, no matter what unit of measurement he used.
Yeah, I mean, in this case, you are just comparing the size of one object to the size of another object. So, like the fact that you're using feet or cubits or whatever doesn't matter.
Now, the skeptic and the reductionist would dismiss this and say, it's just a coincidence, you're just playing with numbers. And I would say, okay, you can believe what you want, but it's there. The numbers are there.
So to summarize his argument, this isn't coincidence, because the numbers are there. Who wants to tell him that the numbers have to be there for it to be a coincidence, too?
I gotta say, like, a lot of different seconds would look cool to us, right? Like, 5 palms, 2 fingers looks to us like a second of, pi over 4. 5 palms, 1 fingers, which shows up in the Pyramid of Khafre, that is in fact exactly a 3-4-5 triangle. You can see 21 over 28 if you cancel out the 7. That's 3 over 4, right? 5 palms, 0 fingers would also look cool to us. It would look like the ratio of the height to one of the sides was roughly the square root of 2, and it would also make the faces of the pyramids almost perfect equilateral triangles.
Ooh, yeah.
And the next second down, remember there's 4 fingers in one palm. The next second down, 19 over 28 or 14, that would look like the calculus constant E. So like it almost like it basically doesn't matter what the Egyptians picked. All of these seconds would look really interesting to us.
So you're saying it's a coincidence?
Yeah, I mean, like basically, I think that is it's just basically the fact that seconds divide by 7 happens to just like there's a whole lot of them that are interesting, and it doesn't really matter what you pick. It's gonna look interesting to people in 2024.
Okay.
And
So go ahead.
what is worth noting though is that the Egyptians seem to have liked the second of 5 palms, 1 finger the best, which is the second used in the Pyramid of Khafre, and quite a few pyramids built after the Pyramid of Khafre, based on casing stones. And it's also like in the Rhind mathematical papyrus, they give you a bunch of like pyramid problems where it's like, if you were building a pyramid with this second or whatever, and they use 5 palms, 1 finger a lot in their examples of pyramids. So
Well,
yeah,
but is it possible that they knew that this was a 3-4-5 triangle?
It's possible, but they also like in neither the Rhind mathematical papyrus nor the Moscow mathematical papyrus, they never show like the knowledge of the Pythagorean theorem. So I mean, like it's possible they got out their cubit sticks and they just measured the long part, like the slope of like the diagonal of their triangles. Like they were building a lot of these, right? But
But Pythagoras is said to have visited Egypt and gotten the idea from the Egyptians. There's a tradition about that.
huh,
But now, not in
yeah, I
the
mean
Old Kingdom. Not in the Old Kingdom.
not in the Old Kingdom, right? Like
Yeah.
Pythagoras is almost 2,000 years later, and I mean, so certainly, like by the time the Rhine Mathematical Papyrus and the Moscow Mathematical Papyrus came out, we do know that somewhere people knew the Pythagorean theorem because it shows up in Babylonian literature, but near like it was kept secret. It had like we find it in individual places. It's not until like the reason it's called the Pythagorean theorem is that Pythagoras made it famous, right? Like it didn't seem to immediately spread. So it's definitely possible they had the Pythagorean theorem, but it didn't show up in like there's 80 problems in like the Rhine mathematical papyrus. It didn't show up in any of them. There's I don't remember how many more, like 30 more in the Moscow mathematical papyrus. It doesn't show up in any of those. So we don't know for sure. It's maybe they had it. So the height of the Great Pyramid is thought to have a ratio of around 7 to 11. And he uses this. Like he literally puts the 11/7 ratio up on screen. Um,
But he
and
doesn't
so
mention pi.
he doesn't mention pi. That is correct.
Interesting.
Um,
Which
so
he could
here's
have.
a well-known pi approximation, right? Like pi is roughly equal to 3 plus 1/7. Like 1/7 goes like 0.142. Pi goes 3.141, right? And or as my parents do it, like I actually have a relative who thought like 22/7 was the exact value of pi. I mean, it's not. It's an approximation. It's a pretty good approximation, but it's an approximation. Anyway, this means that 2 pi is approximately equal to 44/7. We're just multiplying that by 2. But since the height of the pyramid to the side of the pyramid is thought to be a 7 to 11 ratio, that makes the ratio of the height to all four sides together 7 to 44. So to go from the height of the pyramid to the perimeter of the pyramid, we multiply by 44/7, which happens to be the free approximation of 2 pi. And what do you get when you take a radius and multiply by 2 pi? You get a circumference, right? So that's why none of this should take us by surprise, right?
He's obviously looking for numbers to correlate
Yeah,
and saying that somehow this is a message, right? He
yeah.
wants to say that somehow it's a message to people like, if you figure this out, you will see that we are sending you this message of some kind that we
Mm-hmm.
know about the earth or whatever.
Well,
So
he's trying to make a big deal out of the fact that 43,200 shows up a lot of times.
mhm,
And it's like I would argue like no, this is 43,200 maybe showing up once with the polar radius for all that there's a pretty big error value in our knowledge of the height of the pyramid, and he had to stack the pyramid on like take the height of the platform into account in order to get the height that he wanted. It still wasn't tall enough to match up with the shortest radius the Earth has, right?
yeah.
But so he sees 43,200 in that spot, and I'm saying it shouldn't be surprising once you have that you're going to see 43,200 in something that looks a little bit like a circumference, right?
Yeah.
Now, you can dismiss that as being coincidence, but the numbers don't lie. They're there.
Again, his argument is that this is not a coincidence because the numbers exist. The existence of the numbers does not contradict the position that this is a coincidence. The correctness of the numbers would not contradict the position that this is a coincidence. What would contradict the position that this was a coincidence is to show how improbable a coincidence would be. So in general, what do you think about this idea of, measuring things and trying to find correlations to argue that there's intention here? Do you think there's anything to it?
Well, I mean, in general, like you need to in science, for example, you need a statistically significant result, which means that 95% certainty. So the less likely you are to get a correlation, the more convincing the result is, right? So if you are saying stuff is going to be exactly like sides of a building are going to be exactly pi or something like that. Like that, okay, that is a very specific prediction that can be surprising. Randall Carlson has a lot of numbers on the other hand, and it seems to be willing to have a reasonably large error. So, like we're not covering this part of the video, but there's one part where he claims the ratio of like the moon, the diameter of the moon, or actually I think it might be the radius of the moon to the its rotation around the Earth to the like that rotation radius is 108. And the actual value is like 110.6, which I mean you can say it's kind of close, but it is an error value of 2.43%. 108, of course, is one of his sacred or special numbers. But I mean, if we accept this level of error value for all of his sacred numbers, and he presents about 15 in this video, and then there's a whole he implies that he has more as well. Here I have this chart where it's like the width of the black bar is like minus 2.43% from that number to up to plus 2.43% of that number, and you can see like
These numbers
there's
all
a lot of overlap.
the numbers on the bottom of the chart, those are all his sacred numbers.
Yeah, those are all numbers he used. A bunch of them are just numbers that come up when you're using minutes and seconds because they're divisible by 36. One of them he gets out of the Bible. A couple of them are like radius of the Earth or circumference of the Earth. But yeah, so I mean,
Yeah, so all of these, the dashes in the chart, those are all the times that it matches.
yeah, so with the width of the dash matters. Like it's from the bottom of that dash to the top of that dash. Like the very top is like plus 2.43% over that number, and the very bottom is like minus 2.43% over that number. But you can see, like, especially up near like 6,000 to 7,000, like you're gonna get a match almost all the time. The biggest gap is between 2,592 to 3,600. There, he doesn't actually have a whole lot of numbers in between, but overall, like if you just give him a random number, like someone's bank account, he's like it's going to be within about 2% in about 30% of one of his numbers in about 30% of cases.
And this makes the correlation less meaningful because
Yeah,
it
it's
could simply be chance.
yeah, I mean he's like obviously he's cherry picking his examples to show in this video, and then he's also fudging them. Like instead of using the height of the Great Pyramid, he used the height of the Great Pyramid plus the height of the platform it's sitting on, and then he also had multiple Earth radiuses he can compare it to. He can compare it to the average radius, the equatorial radius. He compares it to the shortest one, which is the polar radius, right? So he's doing all sorts of things to like try and make them line up.
Yeah. And if you think about it, he probably tried a bunch of numbers and 70% of them didn't work, but he doesn't tell you about those.
Oh,
He
I'm
only
sure
tells
he
you
did.
about the
Yeah.
30%, right? So it's like, oh, this matches and this matches, and it looks
Yeah.
yeah, and it seems like more significant as a result. Yeah.
Yeah. Like I'm sure he has some even worse matches that he still considers matches, but he's putting his best foot forward, right? Like this is his best work.
Mm-hmm.
So
Uh, but um, it's less likely then that these correlations were intentional, deliberately encoding these numbers into the
yeah,
facts and so
I
forth.
when you have this many numbers that you think could be special to encode, you're just likely to find one of them. You
Mhm.
just have too many different ones that you might find, right? So
Yeah, yeah.
yeah, so I mean, one of his other tricks, and to his credit, he doesn't use this in the Great Pyramid. In the Great Pyramid, he's just talking about like the ratio of the Great Pyramid to aspects of the Earth, right? But
Hmm.
one of his other tricks is that he'll just take a number and he'll switch units. Like he'll switch from like inches to feet to furlongs in one case. He'll look at like two different possible versions of the cubit used by different societies. And like this just gives him more chances to land on one of the numbers he wants. Um,
Yeah. So
so
Yeah, the more if you can fudge a little bit, not only does he fudge as far as like he's got a lot of numbers to choose from, as far as what he
Hmm.
wants to correlate with, he also
Yeah.
has an error margin that he can
He has an error margin.
move,
Yeah.
he can move around that.
Yeah.
But now he also can switch the units of measurement. Well, if
Hmm.
it doesn't work in meters, I'll try feet or whatever and see
Well,
if it.
he never uses metric because he's
Oh,
convinced
okay.
metric is evil or something. But and you
But
can see
something,
why. Like
yeah,
he so I mean that's another thing he does. He claims that every number is if you add zeros at the end of it, it's still the same number, which is it looks similar in base 10, but I mean remember a lot of these numbers come from base 60, right?
yeah,
So now you have every multiple of 6 and then every multiple of 10 and that just sort of spreads out the numbers more. So
yeah.
Referring back to our geodetic data, if we look at the various ellipsoids that give the polar radius, but you'll notice that when we take these various polar radii lengths in feet and divide them by 43,200, you can see the numbers we get right here. Remember, the height of the pyramid is estimated at 482.7575. So looking at this, what you'd see on here, which one would be the closest? Well, you notice it's come out very, very close to the satellite surveys.
For comparison, I checked the NASA figures, and the polar radius in feet is 20,855,485.56. If you divide by Carlson's sacred number, you get 482.7659 feet.
See, when you got to ask yourself, well, why is there a difference between the satellite survey of 72 and the satellite survey of 80? Well, if we did another one again with as high a degree of accuracy, we would discover there's still going to be a discrepancy. And the reason is that the Earth spinning through space, there are various tidal forces working on the Earth which are constantly causing it to distort its shape by up to 2 or 3 or 4 or 500 feet. So we never would be able to get more accurate than 300 or 400 feet because the Earth itself is changing shape. And if we were to measure it every year for the next 10 years, we would get 10 different numbers. They'd all be very close, but they would deviate somewhat because the Earth itself, there are tidal bulges. You know, where's the moon relative to the Earth? That's going to affect. If the moon and the sun are on the same side of the Earth, that will affect the shape of the Earth up to being several hundred feet measured over the diameter of the Earth. And so it is not amiss to say that the pyramid enshrines a measure of the Earth that could be considered as accurate as those determined by modern satellite surveys.
Wait a second. If the deviation of the measurement is up to 500 feet, as he says, then the likelihood of there being an actual match here decreases. But he concludes that it is not amiss, on the ground that it could be considered as accurate. For him, possibility is enough to establish a connection. But remember, he is making the case that there is no coincidence here. By admitting that we don't have precise numbers to compare, he is making a coincidence more likely. A level of precision that is within 500 feet is impressive, but imprecise enough that makes a coincidence more probable.
That to me is a very profound insight because it does suggest that somebody once upon a time was able to measure the Earth's size and shape with that level of precision.
I'm trying to imagine a scenario during the designing of the pyramid where this all makes sense. Someone says, "Hey Bob, what if we put the measurement of the polar radius of the Earth into the pyramid, huh?" And Bob says, "What for?" And he says, "Oh, well, it would be really cool, and we could leave a secret message for the future." And Bob says, What secret message is that?" And he says, "The secret message that we knew the polar radius of the Earth." And Bob says, "That's it? We knew the polar radius?" And he says, "Yeah, wouldn't that be cool?" And Bob says, "If we're going to leave a message for the future, I can think of 1,000 better messages to leave and a lot more helpful ones too." And he says, "No, polar radius is the way to go." And Bob says, "So we would write down, here is the polar radius of the Earth, and then write the measurement?" And he says, "No, we would just have one of the measurements in the pyramid be the same as the polar radius. Well, not the same. People would have to find a secret number key that would unlock it, and then do a bit of number crunching. And Bob says, why would we hide it? And he says, because we want to fool the scientists and make it so only insightful amateurs with faith can find it. And Bob says, sounds good. This will help people in the future to discover that we had advanced science and prove the mainstream narrative wrong. Do you think a conversation resembling this one happened?
And if they were able to do that, what's the implication of that? See, that's the interesting part. Because no primitive culture, using the method of Eratosthenes in about 300 BC in Greece, he measured the Earth and was generally considered to be quite accurate because he was able to get the circumference of the Earth within about 500 miles of its actual measured circumference by using the methods available to the ancient Greeks. You see, and he was considered to be the first to measure by basically putting a stick in the ground and measuring the angle of the shadow on the longest day of the year over a couple of successive years. That's actually an exercise we do in the sacred geometry class because it's very interesting how he did that.
Eratosthenes did the smart thing and wrote a book about how he did it. The Great Pyramid builders did it the stupid way, encode it in the pyramid in the most unintuitive manner possible, make it so the measurements need not only to be found, but also to be adjusted through multiplication or division, and explain nothing.
But he was considered to be, pretty proficient because he was able to determine that the size of the Earth was, the circumference of the Earth was, 25,000 miles, when it's generally considered to be about 24,800, depending on where you measure it. So he was, maybe within 50 miles of the actual dimension of the Earth, but nowhere near as close as the pyramid would have been. So again, even if the pyramid was built 4,200 years ago, you got to say who 4,200 years ago had the technology to measure the Earth with that degree of accuracy.
The degree of accuracy Carlson is proposing is in indirect proportion to his own accuracy. The more inaccurate Carlson is in his measurements and calculations, the more accuracy he can claim the builders had.
Now, that we know of, nobody 4,200 years ago did, or how they would have done it, we don't know. But on the other hand, if it turns out that the pyramid could be much older, it leads us back to the, going back 10,000 or 20,000 years. This to me is one of those little, sort of like the little crack in the dike, that if you don't keep it plugged, the whole edifice of contemporary knowledge could get swept away. Because we can't acknowledge that somebody 10,000 or 20,000 years ago was scientifically sophisticated. That was the days of Cro-Magnon man and Alley-oop living in the cave and so forth. Cavemen, which is a silly idea actually. Yes, I'm sure people did take refuge in caves when things got really crazy out here. Yes, I think people did take refuge in caves.
So here we get to the reason why Carlson has led us all on this numbers trek, to try to demonstrate that there was a lost advanced civilization. It's interesting because this form of argumentation is illustrative of the kinds of arguments we get from people with no expertise in the areas that they're talking about. They don't dig up new artifacts or ruins to show this civilization. In fact, as I discussed in my other video, Carlson says there probably aren't much of any to be found. They don't point to inscriptions written by people who visited this civilization. They don't point to scientific evidence for the existence of this civilization. Instead, they will point to artifacts or ruins from known civilizations and claim that these artifacts actually belong to the lost civilization on the grounds that the known civilization was incapable of building it. And this is exactly what Carlson is doing here. The measurements of the Earth, he argues, are encoded in the Great Pyramid, and therefore the Egyptians couldn't have made it because they didn't know the measurements of the Earth. Never mind the fact that an argument that a known society couldn't have achieved something is not the same as an argument that another society existed. He didn't establish that the measurements of the Earth are encoded in the pyramid at all, because he used faulty measurements, massaged the data to make a match more likely, and to achieve an end result, all the while appealing to the principle of a pseudoscience called sacred geometry, which is based on an ancient Greek religion called Pythagoreanism.
But see, this is one of those things, again, that if you accept that it's not just a coincidence, it opens up a whole can of worms that mainstream science generally doesn't want to address.
If he was using actual science, then maybe they would address it. Note that he says, if you accept that it's not just a coincidence. This is an appeal to faith. He is asking you, the listener, to believe that it's not just a coincidence. And if you believe, then this opens a whole can of worms. Or to use another expression, you will be venturing down the rabbit hole that people like Carlson and others have created for you. Sadly, some unsuspecting people have gone down this rabbit hole and now are stuck in this alternate reality, all because they fell for magic tricks like the one Carlson has performed here.
Because we're the epitome of scientific evolution right here and now, right? Nobody, before we built satellites, could have measured the Earth to within a couple of 100 feet of its actual dimensions.
And we have no evidence that anyone did.
So, given 2 seconds of time, 143,200th part of the daily rotation, a point on the equator will travel a distance precisely equal to the perimeter of the Great Pyramid's base as measured with the socle. In 1/2 second of time, a point on the equator will rotate a distance equal to one side of the base of the Great Pyramid measured with the socle.
I don't know if you know much about the history of the second, but it did not appear in timekeeping until the invention of the mechanical clock about 500 years ago. Granted, the division of the day into 24 hours goes back to ancient Sumer, and the Sumerians used a sexagesimal system, so an hour could be divided into 60 minutes and a minute into 60 seconds, but we have no evidence that the Sumerians ever did that. In all of the thousands of tablets we have found so far, no one ever refers to a minute or a second. Carlson would have you presume not only that the second goes back to the time of the ancient Sumerians, but thousands of years further back than that. He doesn't even try to argue this point, he just assumes it existed. Or maybe I'm misunderstanding him. He's saying that 2 seconds is 1/43,200th of the diurnal rotation of the Earth. So maybe he's not saying that they had the second back then, but rather that there was a unit of time used back then that was equivalent to our 2 seconds, and that there was another unit of time back then that was equivalent to our half second. But let's remember that the number 43,200 was arbitrarily chosen by him.
That there has been some kind of a universal system at use in the ancient world. And these various cultural groups, whether it was the Egyptians or Sumerians or Mayans or the Hopewellians or the megalithic builders, had access to some universal system from some source that was outside their own cultural context. And I suggest that the source of that goes back into deep time, that takes us back beyond the threshold of known history into the realm of mythical history, which means we're going back like into the Ice Age, back into the Pleistocene, to use the geologist term, back into the deep recesses of the human tenure on planet Earth, whose only memory has come down to us not in the form of recorded history, but in the form of myth and epic story and legend and so forth.
In the study of history, sources are very important. But as we know from experience, the further removed from an event or a circumstance that a source is, the less reliable it becomes. This is why historians differentiate between primary sources, sources coming from the time under consideration, and secondary sources, sources coming from another time or place. And we analyze the sources according to the historical method. Now, people like Carlson, who want to establish something as true, but they don't have any primary sources, what do? They appeal to myths. In this way, it looks like they are working with sources, but the problem is that they give just as much credence to secondary sources as they do to primary sources. To them, a story 9,000 years removed from an event is just as good as a story 100 years removed from an event. And they don't use the historical method either. Yes, they admit there might be errors in these stories, but they get to pick and choose whichever parts of the story they wish to hold as true and whatever parts they wish not to hold as true. Moreover, they completely ignore the genre of the story. They categorize a myth as belonging to the historical genre, even though it isn't. If you want a full discussion of this, see my video, How Much History is in Myth.
Because as it turns out, if we, and this is again is a good topic for the sacred geometry class, when we analyze Plato's description of Atlantis, Plato basically gave the date of the sinking of Atlantis as 9,000 years prior to Solon, the Egyptian, the Athenian poet and statesman. Solon did a 10-year exile in Egypt, and it was Solon that brought back the tale of Atlantis and presented it to the Greeks. And Solon basically made that journey around 600 BC. So if you add the 9,000 years to the 600 BC, we come up with a date of about 11,600 years ago for Plato's date for the demise of Atlantis. Well, it's very interesting that the date 11,600 years has been independently discovered by geologists looking at the tempo of various catastrophes that have occurred on Earth.
So we can see some fudging going on here as well. In Plato's Critias, the character Critias says, "Now first of all we must recall the fact that 9,000 is the sum of years since the war occurred, as is recorded, between the dwellers beyond the Pillars of Heracles and all that dwelt within them." The war he's talking about is the war between Athens and Atlantis. He also says, "Consequently, since many great convulsions took place during the 9,000 years, for such was the number of years from that time to this, the soil which has kept breaking away from the highlands during these ages and these disasters forms no pile of sediment worth mentioning as in other regions, but keeps sliding away ceaselessly and disappearing in the deep." Critias clearly is counting from the time of the war to the present time, his present time. The conversation is set in the latter days of Socrates' life, about 410 to 399 BCE. But Carlson needs to match Atlantis' destruction to the end of the Younger Dryas period 11,600 years ago. So he says that actually Critias was counting from the destruction of Atlantis to the time of Solon in 600 BCE. Now, it is true that in Plato's work Timaeus, Critias relates that an Egyptian priest told Solon that he is speaking of events 9,000 years ago. But he does not say this in reference to the destruction of Atlantis, but to the founding of the city of Athens. What we get out of this, really, is that Critias is being very general and round with his figure, and we can't put much stock into its precision. But Carlson needs to do that, and he needs to be able to push back the date to at least the tail end of the Younger Dryas period. So he simply does. He continues to play free and loose with the numbers, stressing the accuracy of the numbers, while at the same time using round and general numbers and adjusting dates as necessary. Anyway, I think we said pretty much all there is to say. I hope this analysis proved helpful to you. I had a lot of fun doing it. Thanks to Caitlin for giving me a mathematical perspective, and thanks to you too for watching and for your support. If you want to learn more about the function of the pyramids, check out my video on the true purpose of the pyramids. Big thanks to all my patrons for keeping the channel alive. If you also want to become a patron, you can do so at patreon.com/worldofantiquity. Or if you prefer to give a little something just once, you can do that with a super thanks. And don't forget, below the video is a link for you to get a 14-day free trial of MyHeritage. You might like my little e-booklet, Why Ancient History Matters. It's designed to persuade people that the subject is important, even in the modern world. You might also wish to use it to help spread the word. So feel free to share it with someone you know. It's free for anyone who wants it. I've left a link in the description box below the video for you to grab a copy. Catch you later.